All right, today we start the inevitable. Section 7 of Chapter 9. We are graphing quadratic inequalities. And inequalities and graphing inequalities always get such a bad reception with students. But from a teacher perspective, this isn't any new information. It's just putting all of the pieces together in one place. And it's just really cool how you can do really impressive things without any new information. So give it a shot. Don't be so negative. This is going to be great. I think you'll enjoy it. I need to zoom out though. I don't know if I can. All right, well, I'm going to do my best with the real estate that I have here. Hey, before we get started, keep in mind, this is not going to be a perfect lesson. I'm going to, of course, be as articulate as possible, but this isn't as good as a regular lesson. So these are just the highlights. So keep that in mind. Okay, so here is our example inequality. Has a y here, could be a 0, too. We don't have to rewrite, though. It's in standard form. Here's the square, here's the x, and then no variable here. So a is 1, b is -3, c is -3. Okie doke. Now, at this point, we have learned how to find the vertex. We have learned how to solve a quadratic equation. Previously, we have learned how to graph and shade an inequality. Now, we're going to do all of it together, and it's going to be so much fun. Okay, x equals -b, or -3 over 2 a's, or 2 1's. Okay, so x equals 3 over 2, or 1.5. Now that you know that, you can put 1.5 in for all of the x's, right? We've done this to find the y. I'm going to do equals because I'm trying to find the value of y right now. 1.5 squared minus 3 1.5s minus 3 equals 2.25 minus 4.5 minus 3, or y equals -7.5 and 5.25. Okay, so now that I know what x is and what y is, these come together to be the vertex, 1.5 and -5.25. Look at those annoying fractions. Can you handle a fraction? You sure can. It's gonna be okay. So I'm gonna go down here to my coordinate plane and find 1.5, -5.25. And that is my vertex. And I'm going to predict that this is going to open up because my leading coefficient is positive. But I don't know where the parabologs are going to come up. Are they going to come up here, or skinny? Actually, there's characteristics using the leading coefficient, but I'm not ready to give you those spoilers quite yet. Today, we're going to use the quadratic formula to find the x-intercepts. So here it comes again. So let's use our information up here to fill in our formula. X equals -b plus or minus the square root of b squared minus 4a. I'm going to drop the 1, c, over 2a's, or 2 1's, that's 2. Keep going. X equals 2 negatives make a positive, plus or minus the square root of -3 squared is 9, plus 12 over Ooh, this one's going to be messy. Ick. 2 equals 3 plus or minus the square root of 20. See where I mean? This is not a perfect square. Equals 3 plus or minus. Okay, so remember when I said that it's really not a good idea to round? So we would want to typically break this down. So like 9 times 3 is 21, square root of 9 is 3, so 3 square roots of 3. But if I asked you to graph the square root of 3, you would know where to put that. So in this case, and this is one of the rare cases, it is appropriate to convert the square root of 21 to a decimal and round. So this would be about 4.58 over 2. See, I make these rules and then I break them. Okay, and so you'll probably want your calculator for this one. 3 minus is negative 1.58 over 2. So it sounds like negative 0.79. And then plus 7.58 over 2 is that, in ascending order. So this is where the parabola is going to intersect at negative, so about 3/4, and at 1, 2, 3, about 3/4, because these make coordinates. This one and that one. Okay, but notice that I have not put a line there yet to connect the dots. Okay, because I'm going to go back to the top. Here's where we remember the old stuff. This is a greater than symbol. Remember that greater than and less than, but not equal to, is a dashed line. If it was greater than or less than and equal to, it would be a solid line. So I'm going to use a dashed line. This is just an estimation, so this isn't perfect. And now shading. This is greater than. Remember when we think of greater than and less than, we think of up and down. So greater than, find the vertex, I'm going to shade up. So for this, that is the region that I'm going to shade. Now to check, well, let me back up. What you've just found is all of these points will satisfy this inequality. And if I wanted to test that, you can just find a point. I love it when it includes the origin, 0, 0. Substitute it back in. Will this balance out? Is 0 greater than negative 3? Yes, it is. So I know that I've shaded the correct region. So let's write down some characteristics. The leading coefficient is positive. So the parabola is going to open up. The inequality is greater than, so the parabola is made up of a dashed line. If it were like this or like this, it would be solid. The inequality is greater than, so the upper part is going to be shaded. And the shaded region represents all the points that satisfy the original inequality. Okay, wow. It's fun to just sit back and look at how much you've learned and what you can do. You guys have come a really long ways this year, and I'm really extremely proud of you. So let's practice this skill. Watching it's one thing, and doing it is quite the other. But I think you'll be just fine. Like I tend to do with these videos, I'd like to give you sample questions using the reverse side so that you have plenty of questions still to do here. Okay, so this first section says to decide whether the ordered pair is a solution of the inequality or not. So this is a yes/no response. So here, let me zoom in. I have 1 and 7, so x and y. If I put in 1 for the x, would it balance out for the y? So is it true that 7 is greater than 1 squared is 1, 6 times 1 is 6, 1 and 6 make 7. I'm working up here. Is 7 greater than 7? It's the same, but is it greater? No. That first one was kind of tricky. Okay, so continue on there. Remember for this one, this is kind of goofing up a lot of kids. It's an old thing, so I hesitate to mention it, but I thought I would. Let's do it here, like number 5. I'm going to write this up here. If I have negative 8x squared, and I need to put in negative 1, what this means is square 1 squared first, which is 1, then multiply by the coefficient, by 8, okay? All right, that's an aside, sorry, that's not quite this lesson. All right, and then we get to match. This is a fun section, I think. Okay, so I recommend that you pick, it doesn't matter, let's do this one here. Okay, so this is y is greater than 1/2 x squared minus 5. So I am just going to look at this leading coefficient. It's positive, so I know that my parabola is going to open up. So b is not 10, b is not 11, it could be 12, could be 13, could be 14, and it's not 15, just because these are the ones that open up, okay? It is greater than or equal to, so that means it's going to have a solid line. So that means 14 is out. So now it's either 12 or 13. And then it is greater than, so it's going to shade up. So now I'm down to 2 of these solutions. Now if you wanted to, you could do the quadratic formula and you could find the legs. You could also, though, find a unique point that's shaded. See how this one has the origin shaded and this one doesn't? So if 0, 0 is included, then that means it's going to that's going to be the graph. It's going to satisfy it. So 0 squared is 0 times, that's 0. Is it true that 0 is greater than or equal to negative 5? Yes, so B goes with 13. That means that 12 must be some other equation that has greater or equal to with a positive leading coefficient, probably E. Okay, all right, and it's a process of elimination. You can keep on going. Maybe not use a marker like I just did. Okay, and then for the bottom, you'll want to have your notes on hand for this. You'll start by finding the vertex, which is a point, so you'll need to do negative b over 2a to find the x. Once you find that x, sub in to find the y. And then for the intercepts, there will be 2 of them. You'll use the whole quadratic equation, negative b plus or minus the square root of b squared minus 4ac over 2a to find the 2 legs. And I will be looking for, does it open up or down? Is it dashed or solid? And are you shading up or down? Okay. All right. Good luck with that. Hey, if you need any help at all, don't hesitate to shoot me a message at dromes@d231.rochelle.net. Happy to help, because I like you. Keep up the good work, and I'll catch you soon. Thanks. Bye.